From hazard tree felling to industrial chippers and high-speed firewood lines, this is serious timber power. Watch whole tree chippers tear through pine. Crews remove dangerous trees with precision, and processors turn massive logs into perfect, uniform fuel. Big engines, smart controls, and safety first. This is modern forestry at work, where every cut, chip, and grind is built for performance. The Peterson 5000H whole tree chipper is built for serious production, turning full trees into clean, uniform chips designed for pulp, biofuel, and pellet operations. Its wide feed opening swallows single stems up to 23 inches in diameter, or bundles of smaller material at once, keeping work moving smoothly with fewer interruptions. Inside, precision engineering takes over. The configurable disc system allows mills to match chip size with exacting standards, whether they prefer longer pieces for certain processes or shorter, more compact chips. With output capabilities reaching up to 100 tons per hour, it's designed to keep pace with high-demand sites while maintaining consistency across mixed wood species and varying moisture levels. Durable components anchor the machine from the core outward. The heavy 66-inch disc is protected by replaceable wear plates, and operators can select cutting systems that best fit their maintenance style and budget. Power comes from efficient Caterpillar diesel engine, paired with adaptive cooling technology that automatically adjusts to workload and climate, saving fuel, trimming operating costs, and extending the life of the machine in demanding forestry environments. The Vermeer WC2500XL whole tree chipper is built for serious production in modern forestry operations. Designed to take on full trees with impressive diameter, it turns tough raw material into clean, uniform chips ideal for pulp, paper, biomass, and energy facilities. A heavy-duty disc and precision knife system work together to keep chip size consistent while maximizing throughput, even under heavy loads. Powered by robust engines and controlled by responsive hydraulic feed systems, the WC2500XL adapts to different species, moisture levels, and debris conditions without sacrificing performance. With rugged construction and an intelligent feed mechanism that helps prevent unnecessary strain, it delivers reliability, reduced downtime, and sustained high-volume output in the harshest working environments. In 2012, a focused effort in Idaho targeted hazardous trees that posed a threat to nearby communities, work sites, and travel corridors. Aging, storm-damaged, and structurally weakened trees were identified as high risk, especially those leaning toward roads, buildings, and utility lines. Skilled forestry crews moved in with professional equipment and a strong emphasis on safety, guiding each fall with precision to avoid unintended impacts. Strict communication, controlled work zones, and constant monitoring helped protect people on the ground while preserving as much healthy surrounding forest as possible. The result was safer landscapes, reduced wildfire and storm hazard potential, and a thoughtful balance between forest health, public safety, and environmental stewardship. The Pzelto PTH14001000M is engineered for operations where power, volume, and reliability are non-negotiable. Driven by an autonomous 800 horsepower Caterpillar C18 engine, it brings industrial strength to demanding wood processing sites, from large timber yards to biomass facilities and energy plants. With a maximum chipping diameter of 700 millimeters and a generous 1400 by 820 millimeter infeed passage, even oversized trunks and bulky sections of wood are guided smoothly toward the drum without slowing production. At the heart of the system is a massive drum, 1,000 millimeters in diameter and 1,400 millimeters wide, delivering an impressive hourly output of 200 to 260 cubic meters of uniform, high-quality chips. A 1,400 millimeter wide, 2-meter chain feed works together with 2 lower rollers to stabilize material, helping maintain chip consistency while protecting the machine from shock loads and irregular pieces. The wide 2,470 millimeter hopper welcomes large volumes at once, reducing handling time and keeping workflow continuous. Built with heavy steel construction and precision engineering, the PTH14001000M balances brute strength with refined control. Its autonomous engine, efficient feeding system, and thoughtful layout ease operator workload, lower downtime, and support sustained production, making it a powerful solution wherever fast, reliable wood reduction is essential. In Koskia, Idaho in 2015, specialized crews were tasked with working ahead of incoming fire personnel, removing burned cedar trees that had become unstable after the blaze. These trees, weakened by heat and internal damage, could fall without warning, creating serious danger for anyone operating in the area. Crews evaluated the landscape, identifying trees with compromised roots, hollow trunks, and heavy lean caused by fire damage. Armed with professional chainsaws and support equipment, they worked methodically but efficiently, taking down the most hazardous trees while coordinating closely with fire managers. Clear communication, protective gear, and carefully controlled work zones helped ensure everyone remained safe while the job progressed. The result was a safer corridor where firefighters, support teams, and vehicles could move freely and concentrate on their mission without the constant threat of falling timber. Beyond immediate safety, this effort also laid critical groundwork for recovery work that followed, stabilizing the environment, protecting crews, and helping restore order to a forest landscape still recovering from intense fire activity. The Logcon firewood production line, combined with the Pzelto C750.2 firewood processor, creates a powerful, industrial-grade system built for continuous, high-volume production. It's designed around efficiency, moving logs from raw stock to finished, packaged firewood with minimal manual handling, steady flow, and dependable performance across long shifts. For commercial producers, that means predictable output, reduced labor strain, and a process that stays organized even when demand is high. The line begins with Logcon's heavy-duty material handling components, engineered to manage large volumes of timber with stability and control. Robust in-feed and roundwood decks work together with chain-driven conveyors, fitted with V-shaped cradles that cradle and position each log securely. With deck widths of 2.4 or 4 meters and lengths available at 8 or 16 meters, operators can tailor the system to the space they have and the production capacity they need. Each deck is rated to carry up to 30 tons, offering both storage and buffering capacity, so the processor is constantly supplied without frequent interruptions. The roundwood deck also plays a critical role as a step feeder, advancing logs one at a time toward the Pzelto C750.2. This controlled pacing is key. It keeps the processor working smoothly, supports accurate sawing and splitting, and helps prevent jams that can slow production. Once the logs reach the Pzelto unit, they move through powerful cutting and splitting cycles that deliver uniform firewood ready for handling, drying, or packaging. By pairing Logcon's expertise in material flow with the high-performance mechanics of the Pzelto C750.2, the integrated line brings together speed, consistency, and reliability. The result is a streamlined firewood operation capable of producing large volumes while maintaining quality, minimizing downtime, and creating a safer, more efficient working environment for industrial firewood producers. The Bosch K650 firewood processor, commonly known through the Spaltfix K650 Vario series, is designed for serious, professional firewood production where precision and volume both matter. Built for industrial operations, it brings sawing and splitting together in one continuous, automated workflow, turning large diameter logs up to 65 centimeters into clean, uniform billets. Edge lengths can be adjusted between 5 and 15 centimeters, allowing producers to tailor output to different markets, heating systems, and customer preferences. At the heart of the machine is an intelligent hydraulic in-feed system with manipulators and rollers that stabilize each log and guide it into the power cut saw unit. With options like the Supercut Harvester chainsaw and automatic double gripper control, the K650 maintains accurate cutting even when logs are crooked, knotted, or irregular. Once cut, billets move smoothly along a buffer belt toward the AutoSplit 650 splitting system, where roughly 16 tons of splitting force converts each piece into consistent firewood, all with minimal manual effort. Advanced electronics further elevate performance. Touchscreen controls, optical sensors, and integrated safety systems monitor log position, machine load, and splitting sequences, adjusting automatically to keep production flowing while protecting operators and equipment. Dust and chip extraction connections help maintain cleaner work zones, and optional conveyors can move finished wood straight into storage, bagging, or transport. With high throughput, rugged construction, and automation designed for long, demanding shifts, the Posh K650 stands out as a reliable centerpiece for commercial firewood plants, delivering speed, accuracy, and dependable product quality on every run. The Lankman SAF-700 circular saw with conveyor is built for professional firewood operations that need speed, accuracy, and dependable safety. At its core is a powerful 700mm circular blade mounted on a solid cutting trestle, giving the operator a stable platform and precise, repeatable cuts across different log sizes. Logs stay securely positioned during cutting, which not only improves accuracy, but also reduces vibration and wear on the machine over time. An integrated log feeding conveyor, often referred to as a tapis montebois, keeps material moving steadily, minimizing physical lifting and significantly boosting productivity when working through larger batches of timber. Whether used in farms, sawmills, or semi-industrial yards, it helps maintain a continuous workflow instead of stop-and-start handling. The SAF-700 is also designed with flexibility in mind. It can operate via tractor PTO, a 7.5 kilowatt three-phase electric motor, or a combination setup, allowing it to adapt to fixed installations or mobile work sites. Conveyor options of 4 or 5 meters make it easier to match different layouts and timber lengths, while an optional hydraulic lifting table raises logs to an ergonomic cutting height, reducing strain on the operator. Rugged construction, thoughtful ergonomics, and versatile power options come together to make the Lankman SAF-700 a reliable solution for serious firewood preparation, delivering consistent results, safer working conditions, and efficient throughput in demanding environments. The Morbar 1100 tub grinder is built for operations that need serious material reduction, turning wood waste, land clearing debris, and storm-damaged material into usable biomass and mulch. Driven by a powerful diesel engine, it channels that energy into a rugged hammer mill equipped with replaceable forged hammers and adjustable screens, allowing operators to fine-tune the finished particle size for different end uses. The large rotating steel tub helps pull material evenly toward the mill, reducing surges and keeping production steady, while hydraulic augers beneath the grinding chamber manage the discharge flow and help prevent buildup or clogging. Electronic monitoring systems oversee key functions, managing engine load, coordinating the clutch and tub speed, and automatically adjusting operations to protect major components. The result is a grinder engineered for continuous duty, improved fuel efficiency, and dependable performance in demanding recycling and biomass environments. Stump removal doesn't always require excavators, winches, or heavy construction equipment. With the right mechanical setup, it can be achieved in a controlled, efficient way that relies more on physics than on brute force. The principle centers on distributing load evenly and lifting the stump vertically so the surrounding ground stays intact and the forces acting on the system remain predictable and manageable. A triangular framework built from heavy-duty masonry props becomes the backbone of the system. Arranged around the stump, they form a stable, self-supporting structure that resists tilting, spreading, and twisting, even when the soil is soft or the ground is slightly uneven. This triangular geometry is key. It channels force downward into the ground rather than sideways into the operator or the surrounding area, creating a secure lifting frame that can handle both vertical pressure and lateral stresses as the stump starts to move. Mounted at the upper junction of this framework is a manually operated chain hoist rated for significant load. When the stump is connected through the hoist chain or cable, ideally to solid remaining trunk wood or strong primary roots, the system begins working like a slow, powerful lever. Each pull on the hoist adds controlled tension, increasing lifting force without sudden jumps or unpredictable movements. Instead of ripping the stump free in one violent motion, the force is applied gradually, and the operator can feel the resistance change as roots begin to loosen. As the upward pull continues, the soil around the root network gives way in stages. Fine roots shear off first, then larger anchor roots begin to fracture and release. Because the lift is vertical, the root ball rises out of the ground rather than dragging sideways, which helps preserve surrounding landscaping and prevents deep ruts or torn turf. The props absorb and distribute the strain, keeping the structure rigid while the stump slowly separates from the soil. In some situations, removing a bit of soil around exposed roots beforehand makes the process even cleaner. Reducing the amount of soil gripping the root network means the hoist works more efficiently and the extraction happens faster, while still maintaining control. Throughout the operation, the frame, props, and hoist work together like a single engineered unit, each component sharing load and preventing overstress at any one point. Technically, the benefits are significant. The equipment is relatively inexpensive, easy to transport, and requires no fuel, hydraulics, or external power source. The setup is compact enough for gardens, narrow access areas, and remote properties where heavy machines can't reach or would cause damage. And because the lifting force is progressive and measurable, it allows for safer working conditions when used correctly and within rated limits. In the end, this method demonstrates how thoughtful engineering can replace heavy machinery, using leverage, geometry, and controlled lifting to remove stubborn stumps with less effort, less disturbance, and a remarkably efficient use of simple mechanical tools. Felling a pine tree with a controlled, angled fall is less about brute strength and far more about understanding how trees behave as living structures. Pine, in particular, brings a unique combination of straight grain, long wood fibers, and resin-saturated cells that respond quickly once fibers are weakened. These traits make pine predictable when handled correctly, yet unforgiving when misjudged, which is why thoughtful planning and precise execution are essential. Everything begins long before any cutting takes place. A careful look at the environment reveals how the tree interacts with the landscape. The natural lean of the trunk, subtle shifts in terrain, moisture conditions in the soil, and the way the crown spreads all influence how forces are distributed. Pines often develop heavier branching on one side due to sunlight exposure and competition from neighboring trees. That added weight quietly shifts the center of gravity, nudging the tree toward the heavy side. Recognizing that tendency and aligning the planned fall with it whenever possible reduces strain in the wood and minimizes the chances of cracking, tearing, or unpredictable rotation. Wind also plays a role. Even a modest, steady breeze can amplify leverage at the crown and transform a marginally safe situation into a dangerous one. Similarly, slopes, rocks, and root exposure can affect stability. When all of these details are read together like clues, they reveal how the tree wants to move and how an angled fall can be guided with greater confidence. Directional control in forestry hinges on an elegant concept, weakening structural fibers in a controlled pattern while intentionally preserving others. The guiding geometry created at the base of the trunk establishes where rotation will begin and how the trunk will behave as it tips. With pine, precision matters. Because the fibers are long and continuous, tension can travel through the trunk very quickly. Rough or uneven cuts concentrate stress, increasing the likelihood of splits running upward through the stem. Clean, deliberate geometry keeps stress distributed and prevents sudden failure. At the center of this method is the hinge, a thin band of intact fibers that acts like a flexible steering joint. Rather than snapping instantly, these fibers bend, hold, and gradually release as the tree descends. When the hinge is consistent across the stump, forces stay balanced from side to side. If the hinge is uneven, fibers on one side can fail first, allowing the tree to twist off course. In dense forests, or anywhere near roads, fences, or structures, that twist can turn a routine operation into a serious hazard. As the fall begins, the tree moves through distinct stages of motion. At first, it flexes like a giant spring storing energy in the bending wood. Then, once gravity overcomes the last resisting fibers, motion shifts into controlled acceleration along the planned trajectory. If alignment, geometry, and natural lean have been correctly accounted for, the tree follows the intended angle smoothly, without sudden swings or backward motion. Only in the final moments, as trunk, branches, and ground meet, does the kinetic energy dissipate in cracking limbs, dust, and vibration. What follows after contact is often overlooked, yet it is one of the main reasons directional felling matters so much. A properly oriented tree lands where it can be safely processed. Straight, angled placement makes bucking, sorting, and extraction more efficient and reduces the need for extra handling or machine maneuvering. It also protects surrounding vegetation, reduces soil disturbance, and lowers the risk of residual damage to nearby assets. Ultimately, controlled, angled felling of pine is an exercise in applied physics and biological understanding. It blends knowledge of fiber strength, gravity, balance, and rotation with environmental awareness and disciplined cutting geometry. When executed by trained professionals, it transforms a potentially chaotic event into a deliberate, predictable motion, prioritizing safety, accuracy, and respect for both the operator and the forest itself. The Bandit 21XP is built for serious production work, especially in environments where dense, abrasive Australian hardwoods can challenge lesser machines. With engine options climbing to 275 horsepower, it delivers strong torque at the knives, keeping the chipper working efficiently, even when the material is knotty, twisted, or oversized. Its generous in-feed dimensions, 24.5 inches high by 26 inches wide, give operators room to work, and although it's nominally rated at 21 inches, the 21XP can comfortably process logs approaching 24 inches thanks to its open throat design and powerful cutting chamber. What really defines the machine is control. Borrowed from Bandit's larger whole tree platforms, the hydraulic feed system features a chain-driven upper feed wheel, paired with a heavy lower wheel that grips and drives material forward with authority. This synchronized feed keeps logs aligned, reduces stalls, and limits the amount of repositioning the operator needs to do. A wide, flared hopper and solid in-feed tray make it easier to fold branches and irregular hardwood stems into the chipper, supporting continuous work during land clearing, right-of-way maintenance, storm cleanup, and biomass production. Rugged construction, reliable hydraulics, and a cutting system designed to hold an edge in tough timber give the Bandit 21XP the capacity and durability demanded by professional crews working in harsh conditions. A disc chipper designed for thin branches offers a compact, highly efficient way to deal with pruning residues, brushwood, and other small diameter material that would otherwise be difficult to manage. At the core of the machine is a fast-spinning steel disc fitted with precisely aligned knives. As branches enter the cutting chamber, the knives slice them cleanly against a fixed counter knife, producing uniform chips with predictable size and shape. This disc cutting principle delivers smooth operation with minimal vibration, while the clean slicing action preserves chip quality for uses such as composting, mulching, and small-scale biomass production. The in-feed chute is shaped to guide material naturally toward the disc, helping orient branches, reduce snagging, and limit the risk of kickback. Because the design is mechanically simple, with fewer moving parts than heavier industrial chippers, maintenance remains straightforward and reliability stays high, even with frequent use. Lightweight, economical, and easy to transport, disc chippers for thin branches are widely used in municipal green space care, landscaping companies, orchards, vineyards, and forestry cleanup operations. They provide a practical way to transform what would be waste into a usable resource, combining safety, efficiency, and consistent output in a compact form factor well suited to everyday fieldwork. Gasoline-powered chippers, designed for both cutting logs into sections and shredding them into chips, are built around three priorities: performance, mobility, and independence from external power sources. Remet's gasoline chipper lineup is engineered specifically with fieldwork in mind, allowing operators to stay productive even in remote areas where electricity isn't available. The result is a machine platform that can move easily from site to site while still delivering the strength needed for heavy, continuous workloads. At the heart of these units are durable internal combustion engines that produce steady torque and strong cutting force. Branches, wood waste, and small logs are transformed into uniform chips as material passes through precision machined cutting systems. Hardened knives and counter knives maintain sharp edges over long service intervals, while carefully shaped cutting chambers promote smooth material flow and consistent chip size. Models such as the RS100, RTS300, RS120 Hybrid, RTS630 Off-Road, RS120 Off-Road, and HRS80 benefit from Remet CNC manufacturing, ensuring tight tolerances, structural rigidity, and long-term reliability. Despite their capability, these machines remain compact and transportable. Balanced chassis designs make towing or repositioning straightforward, and off-road variants incorporate reinforced frames, improved ground clearance, and rugged running gear to cope with rutted tracks and uneven terrain, ideal for forestry, farm, and rural service work. Hybrid versions further optimize fuel efficiency without compromising output, delivering economical operation across long days in the field. Layered safety protections, controlled in-feed systems, and robust housings help safeguard operators while supporting dependable daily performance. Because they combine engine efficiency, durable engineering, and true mobility, Remet gasoline chippers provide a versatile solution for gardens, orchards, agricultural sites, contractor work, and forestry applications, turning raw wood into manageable sections and high-quality chips wherever they are needed.